Good afternoon, everybody, and very warm welcome to this, the latest in the Food Farming Countryside Commission's series of workshops, Routes to Action. I'm Patrick Casement. I'm the chair of the FFCC's Northern Ireland inquiry. To start with, I just want to say a couple of words about what this series is about. It's to help make sense of the idea of agroecology in practice at scale in the United Kingdom. And it's about bringing forward ideas on the potential for transforming our agricultural system by 2030. It's building on the research that we commissioned for our report, Farming for Change, which came out in January. We've held 6 sessions in this series so far, starting earlier in the year, 5 themed workshops on agronomy, land management, economics, culture, and policy. We're now holding a series from the devolved countries, and the first one was yesterday from Scotland, and today's is coming to you from Northern Ireland. We'll be using these sessions to inform further modelling on our next report, which we hope will come out in the spring. Before we start, just a couple of words on housekeeping. This session is being recorded and will be available later online. But can I ask you all at this stage to keep your microphones muted? But you're very happy to see your cameras on. There's no problem with that. And please do contribute through the chat function. We're going to have 4 panelists speaking briefly, and there will be opportunities for you to pose questions to them, both individually and as a panel. If you can use the chat function to pose your question and to leave any comments or evidence that you want to put to the workshop. I just want to say a very few words of introduction, sort of context for this, particularly about Northern Ireland, actually. Agriculture in Northern Ireland remains a really important sector in our economy. This is in contrast to much of the UK, really, where agriculture is pretty marginal in many ways in economic terms. Agriculture here in Northern Ireland is almost entirely grass-based, with a very strong emphasis on livestock and a very large number of small or very small farms. From about 5.6% of the UK's land area, Northern Ireland produces 15% of the UK's dairy and beef produce, 14% of its pork, and 13% of its poultry and eggs. The downside of all this production is that the agricultural sector is the largest single contributor to greenhouse gas emissions in Northern Ireland, contributing 23% of those emissions. However, I think we'd have to recognise that this figure only covers the emissions that come directly from agriculture. It doesn't take account of the ability of agricultural land to sequester and store carbon in its soils and vegetation. And I think one of the things we really want to get to grips with is what the net position of agricultural sector is. Northern Ireland soils, in fact, contain some of the highest levels of organic matter anywhere in Europe. It's helped by the fact that a significant portion of the country is covered in peat, of course, but at the same time, permanent pasture holds a lot higher levels of carbon than most arable land. We also have the lowest level of tree cover anywhere in Europe at only 8.3%. And have a remarkable, though, hedgerow resource of more than 1 kilometre of hedgerow per hectare of land. Given the climate emergency, we urgently need to both reduce our emissions from agriculture and to increase our carbon sequestration. But first of all, I think we have to understand better what our true net baseline position is, so that we can monitor our progress and establish the effectiveness of any measures that we adopt to improve our footprint. Hence, the need to accurately measure farm carbon, as exemplified by the 3 of the projects we're going to hear about today. And then we're going to round off with a look at some of the measures we can then introduce to improve our carbon balances. I'm going to start by asking Phil Carson from the RSPB here in Northern Ireland to say a few words about a project the RSPB have been involved in. Phil is the RSPB's expert on sustainable farming, and he's worked on a range of projects with them around that, but the latest one has been a carbon audit project. Phil, over to you.
Apologies, Patrick. I was trying to unmute there and it didn't quite work. Technical difficulties, but I will start sharing my screen now if everyone can see. Can you see that okay?
Yes.
Perfect, thank you. Yeah, thank you, Patrick, and good afternoon, everyone. So yes, I'm Phil Carson from the RSPB, and really delighted to be here to discuss one of our projects looking at carbon auditing and trying to incorporate the needs of nature into that and trying to demonstrate, I suppose, the value in that and help contribute towards getting a baseline for some of the farms that we work on. So as Patrick said, we've got a big challenge ahead of us in terms of meeting any climate targets that will be in front of us in terms of reducing direct emissions, but also increasing the storage capacity of our land and sequestering carbon through land management. And one of the things I kind of want to make a point about here is that we've only got so much land and we have to be careful and really strategic about how we use that to try and get the best outcomes as possible. And I think with an approach that tries to maximize co-benefits, that's going to be really important, because looking just narrowly at carbon and carbon alone can lead to negative impacts in other areas, which we don't want to see. And just to talk about some of the outcomes that we need to meet from our land. So obviously we're in a climate emergency, but we're also in a nature emergency as well. So recently we've seen that 25% of all bird species on the island of Ireland are now red listed. We've seen declines in water quality, and we've seen declines in air quality as well. So we need to be able to look at maximising the improvements in those areas, as well as delivering climate mitigation. And land is going to be really, really important in doing that. And of course, also we're going to have to be able to produce food too. But I think we need to be able to avoid perverse and harmful outcomes, capitalise on synergies and co-benefits, and focus on a transition to overall sustainability. And I think agroecology has a key role to play within that. So just to set a little bit of background about some work that we had done previously to try and determine where co-benefits can be achieved and where potentially there's risks in terms of climate mitigation and the impact that it might have on resource protection and biodiversity. So this is a large-scale literature review that looked at a range of different mitigation measures that could be applied to agriculture, and it tried to rank them in terms of priorities that could meet multiple objectives all at the same time. And I'm not going to go through each of them individually, but what we can see is restoring nature is key within this and can deliver loads of co-benefits, but also changes in farming practices and farming systems can play a key role within that as well. There's some elements which may provide a risk to biodiversity, and then there's risks to resource protection as well with some of these. So I think we need to be careful in terms of what we prioritise and where we prioritise it as well, because even though we're small, we have quite a diverse landscapes which will need to deliver different outcomes from that land. So based on this, we wanted to try and determine what the climate impact was of some farms that we worked with in Northern Ireland. So we work across a range of different landscapes, particularly trying to focus on delivering benefits for priority species and priority habitats. So that ranges from lowland wet grassland in Fornara to the uplands of Glenwary to East County Down, where it's a focus on mixed and arable farming. And this is something new for us to really look at carbon. We know that nature's got an important role to play in it. Agriculture's got an important role to play, but how do you start bringing those things together? So what we wanted to do was to provide an illustrative example of different farming systems and look at opportunities to reduce emissions, but also opportunities to increase sequestration and carbon storage, and also to discuss potential barriers with farmers as well in terms of what would be needed to support them on a transition, whether that's through support or advice or interventions in terms of financial support. So we worked with the Farm Carbon Consultancy, who do a lot of work across the UK, helping farmers to determine their baselines, and also in terms of delivering action plans which will guide progress and bring that forward. And what we wanted to do was to see how the needs of nature could potentially be incorporated within that as well. So just in terms of process, we began this work in April last year, just as we went into the first lockdown. And the intention was to have farm visits with FCT and to go really in depth with a lot of this stuff. Unfortunately, we had to move a lot of it online and work with the farmers in different areas to try and get as much data as across to FCT as possible. So what we did was to deliver an initial carbon audit, which focused on a range of different areas in terms of inputs, in terms of livestock, in terms of farm machinery and fuel use as well. And then after that, there was an action plan, an indicative action plan developed by FCT in terms of actions which could reduce emissions, but also increase sequestration as well. So just a little bit of an overview of the different farms that we looked at. So we looked at a couple of livestock enterprises, one dairy and one, I suppose you would typify as an HNV farming system with a range of semi-natural habitats, low intensity grazing on that system. And we'll also looked at a mixed farm and also a farm predominantly focused on arable. And I think this, whilst we are predominantly livestock based, it demonstrates, I suppose, the diversity of our landscapes and the potential different approaches that need to be adopted in different areas. In terms of the initial audits, what we found was obviously, as you'd expect, a different profile of emissions across each of the different farms. So you can see Farm 1 and Farm 3 heavily livestock based, so a lot of the emissions emanate from there. In terms of Farm 2 and Farm 4, it's a bit more of an even mix in terms of inputs, fuel, and then also a little bit in terms of livestock too. And that guides the kind of priorities and the strategies that FCT looked at in terms of advising farmers in terms of where they could go. In terms of total emissions, we found that the lowest, I suppose the farm with the lowest emissions was around 340 tonnes per year, with the highest being around 3,000. So there's quite a big range as well there, depending on farming system and farming type. And that's all really important in terms of guiding strategies. One of the things that was a bit of a gap in our study was access in terms of soil testing and soil analysis. Some of the farms that we work with had been undertaking that regularly, whilst others hadn't been in the past. And I think that's something that the other speakers will be talking about, but is a key important component of this moving forward. So just in terms of potential strategies, again, highly context specific in terms of where interventions can be delivered. But in terms of opportunities, there is some for low-hanging fruit. So we find that some interventions in terms of better input management, nutrient management, and also in terms of trying to increase sequestration through the incorporation of different habitats could potentially reduce emissions by 5 to 20% over a reasonably short period of time. But that's different depending on the farming system in play, but between 5 and 20% depending on the farm. Some of these could be delivered at relatively low cost and at gain to the farming system in terms of better efficiencies. But then beyond that will require probably significant investment, and some of the proposed interventions wouldn't currently fit within a farm business model at this point in time. And I think policy has a key role in trying to overcome some of those as well. Some of the key elements too is managing existing store as well. So I know that I'd mentioned one of the farms was the HNV system, and those habitats are particularly crucial in terms of acting as a carbon store in the long term. One of the useful things about this calculator was it tries to calculate the sequestration value of green infrastructure around the farm, and with soil testing it does that as well. And what we find that there's I suppose, a really important contribution that nature can provide on these habitats, either through well-managed existing stores, such as semi-natural grasslands, or created habitats throughout the farm system. And one farm in particular, we found that if it moved from, I suppose, 5% of the land dedicated to nature as it is currently towards 10%, that would sequester an additional 168 tonnes per year. For the farms that did undertake soil carbon tests, they found that there was potential, and there had already been increases in soil organic matter in previous years. And it estimated within the calculator there could be significant savings in terms of, significant increases in terms of soil carbon storage if that continued on. And I think that reinforces the need for regular soil testing and a role for that to play moving forward. Just in terms of wrapping up and our thoughts on this, and this was an investigation into carbon auditing for us, and the first time that we've done that. And I would say it's a journey. It's a really important part in the process in terms of delivering that baseline and it needs to be accurate and it needs to inform decision making. But I think as well, on top of carbon, there's also a role for trying to undertake biodiversity audits, and also in terms of other potential audits that can help maximize opportunities for synergies, but also avoid any potential negative outcomes as well. So again, I think it's the point about integrating and not isolating. At a wider context, I think there's a role for strategic land use planning in this. So what interventions will deliver the best outcomes and where? So for example, this map on the right shows where our existing high carbon stores are, and as you can see, they're related to PD habitats and potential high nature value areas as well. So is a focus on efficiency in those areas going to deliver those maximum benefits, or is it a less is more approach to production and more extensive farming and managing in line with the natural carrying capacity of the land? So I think strategic land use planning will be really important. Finally, the need for joined up support and advice in terms of biodiversity, in terms of resource protection and carbon. I think we all need to improve our carbon literacy in this regard and try and work together to make sure our messaging is aligned and opportunities are maximised within this. And then finally, just in terms of long-term direction of travel, incorporating the needs of climate and nature centrally within agricultural policy and helping to inform that baseline and guide strategic action moving forward will be really key. And that is a very quick overview, but thank you for that.
Great, thank you, Phil, very much for that. A couple of questions have come through here. And the first one is, are there any similar studies being done by RSPB in other parts of the United Kingdom, particularly in England?
Yes, so we have taken an increased interest in carbon auditing and also trying to deliver a more strategic approach to land use. So there's a couple of projects that have looked at the top level, and one of them has tried to determine where our greatest carbon stores are and the need to protect those sites, but also the climate mitigation potential of peatland restoration and the climate mitigation potential and strategic land use planning in terms of woodland creation. In terms of carbon auditing specifically, I know there are plans to trial different tools on Hope Farm and try and determine what the potential benefits and I suppose ways that we can incorporate the needs of nature into auditing on that system and potential for rollout in other areas too.
Great, thank you. And the other question that's come through is really interesting and is an important one is did you take account of methane production from the livestock, and how did you assess that?
Yeah, so we actually trialed on on all the farms. We used GWP 100, but we also used GWP star to compare those as well and look at the different, I suppose, impacts that those would have. And what we also did was we modelled, because we had one of these farms that was in I suppose an upland landscape, and we'd previously looked at it, less is more, Chris Clark report, which looked at maximum sustainable output and matching your stocking rates with the land's natural carrying capacity. And what it found was generally where we could reduce in those areas and maximize profit as a result. So we applied a reduction in those areas on both GWP star and GWP 100 and saw what the potential climate impact would be on both of those sites.
Great. And a final question, do you think it would be better for to get a lot of farms getting a 5% reduction in emissions through getting the low-hanging fruit, or get a fewer farms working harder to get a much bigger reduction, say 50% of their emissions reviews? Do you have a view on that?
I think it depends where you are and what could be achieved within each landscape. I think every farm should be trying to do as much as possible. But say, for example, like I think there's going to be opportunities within moving towards net zero as well. So say you have a farm in an upland landscape and you have peatland, and there's a carbon price for that in the future, that could become an important part of your income stream, and you could be carbon negative as a result of that. Whereas maybe in more in higher intensities, higher input, higher output systems, you mightn't be able to get the same win. But I think we should be striving as much as possible across the board.
Great. Thank you, Phil. That's wonderful. I think we're going to move on then to our second presentation, and I'm going to ask Aleathea Brown from the College for Agriculture, Food and Rural Enterprise in Northern Ireland to talk a bit about the project that they've been doing on their farms within CAFRE. Aleathea, over to you.
Okay, thank you. Can you hear me okay, Patrick and Verity? Yep. You hear me okay? Yes? Yes.
Yes.
Hello, everyone. Thank you for inviting me along today, Patrick. So just to introduce myself, my name is Aleathea Brown and I work for the College of Agriculture, Food and Rural Enterprise here in Northern Ireland. My role within CAFRE, I am an agricultural technologist, and I provide education to the industry on topics such as carbon, and I would use our 3 farms here at CAFRE to demonstrate knowledge and technology transfer projects to the farming industry. So today I'm going to talk about CAFRE, who we are and what we do. I'm then going to introduce our 3 farms and talk about the technology projects that I have implemented on our 3 farms over the past year or so. And then finally, talk about how we at CAFRE here roll out these technology projects through our education and adoption through our schemes and programs. So CAFRE College, CAFRE, we have 3 sites here in Northern Ireland. We operate here at Greenmount, where I am today, in Antrim, and we have a campus in Cookstown at Loughrea, and we also have our equine campus in Enniskillen. So we provide education and training on subjects of agriculture, agribusiness, food technology, horticulture, and equine. We educate approximately 1,700 students, and we provide and we work with farmers, approximately 5,000 farmers, on various advisory programs. And one role, what I was just talking about, I do myself, is developing and demonstrating knowledge and technology transfer projects for the farming industry. So that's what we do here at CAFRE. So to introduce our 3 farms, we have 2 lowland farms here, Dairy Centre and our Beef and Sheep Centre. Our Dairy Centre consists of 160 hectares of grassland, 200 Holstein dairy cows plus followers, and 30 hectares of crops. Our Beef and Sheep Centre consists of 130 hectares of grassland, 80 suckler cows, 160 finishing cattle, 210 breeding ewes, and a small area of cereals, 5 hectares. In contrast, we have a hill farm, the Glenwary Hill Farm, vast amount of land, approximately 1,000 hectares, which includes grassland, heather-dominated modified bog, grass-dominated modified bog, with 110 suckler cows, 1,100 breeding ewes, and has a strong environmental focus, supporting Northern Ireland priority species such as Irish hare, red grouse, curlew, and foraging areas for hen harrier. So today's theme is all about measuring a farm carbon and managing. So today my technologies are focusing on measuring our farm carbon baseline for all 3 farms, what technology I used, and then also the second technology was a survey, a Lidar survey that we conducted last year to measure the carbon storage and sequestration in our trees and hedgerows here at the 3 farms. So to introduce, first technology was measuring your farm carbon footprint. I have just listed a number of calculators here, but at CAFRE, what we recommend is just identifying a calculator that works best for your farm or best for your business. There are many more calculators out there to use. So first and foremost, pick your calculator, then follow with the process. The process involved farm data collection. So the data that we would need to collect on farm would cover your land use and crops, livestock performance, and also energy and waste. So whenever you collect all that data, you run it through the calculator that you've picked, and you would come out with a report, something that looks similar to this that's on the screen here. The the report. This is the first part of the report. The next slide, I'm going to show the second part of the report. So as you can see, the first part page of the report includes, where what emissions arise from your farm, the source of those emissions, and a quantification of those emissions. So when you get your report, then interpretation is key. So these are results here from our CAFRE and beef and sheep centre. So at the bottom there, you can see our net emissions for our beef and sheep centre come to 1,600 tonnes of carbon dioxide equivalent. And if we look at the pie chart, we can see the majority of those emissions are attributed to methane at 56%, followed by emissions attributed to nitrous oxide at 24%, and emissions associated with carbon dioxide at 20%. And if we look across then to the bar chart, this provides the emission by source on our beef and sheep farm. And you can see the majority of emissions are arising from enteric fermentation on farm, manure management, fertilizer, and purchase feed. So whenever we are thinking about mitigation strategies here at CAFRE, those are the 4 areas that we are looking at on our beef farm to mitigate emissions. If you read the bottom of the screen there, I've also presented our efficiency figure. For our beef enterprise, we're sitting at 27 kilograms of carbon dioxide equivalent per kilogram of dead weight. And whenever we run this through the calculator and benchmarked against similar systems in the industry, we were performing extremely high there. You can see we're performing well. But after speaking with our farm manager and beef technologist, I am aware that our beef, this farm is one of the top performing farms in Northern Ireland. And whenever they run it through the financial benchmark and the physical benchmarks, similar for our sheep enterprise, we're performing very well in terms of efficiency. So that was just an example of a carbon footprint report and interpretation. And whenever what we're doing now is putting in mitigation strategies in place, short-term and long-term. So that was the first technology. This is the second technology then that I have implemented on our CAFRE farms, which is a Lidar survey across all 3 farms. It's basically a flight that took place last April that had a laser scanner, a sensor, and a GPS device attached to the wing of the aircraft. And it flew over our 3 farms, and it pulsed out laser, millions of pulses, and was able to, the sensor measures the distance between the plane and the object. And it provides a lot of data to measure the topography and landscape of our farms. Now, when this data, it provides high resolution readings. When this data is then presented back to us, what we did was collaborate with AFBI, our Agriculture, Food and Biosciences Institute, and who are conducting an analysis on the data to measure our carbon storage across our farm and also our carbon sequestration, and that's in our trees and hedgerows. So unfortunately, I don't have the results of these today. The project with AFBI is due to finish at the end of this month, but it's a very exciting project, and it will help towards identifying, how much emissions we are offsetting on our farms. So finally, how do we roll these technologies out then across the industry? Well, we are running a pilot project within the Environmental Farming Business Development Group programme. The programme takes a group approach to learning, sharing knowledge, and implementing and improving technical efficiency on farm. So currently we are carbon footprinting and carbon benchmarking 220 farms within these groups. It is progressing well, but just like Philip, we started last year, and the remote collection of data is proving difficult. So we have got a lot of interest there. We're just waiting to collect much of the data. As part of this, our agriculture environment advisors are out working with the farmer. So they're in constant contact. They're there to help with interpretation of reports, and also to suggest options in terms of mitigating carbon emissions on their farm. It is a targeted carbon mitigation plan for each farmer. So the outcomes of this pilot project will inform future programs and schemes going forward. So that is my talk there finished, Patrick. If we want to take any questions.
Thank you very much indeed, Aleathea. I think we've got a few questions coming in. And one of them is actually a very technical question really in many ways, and that is about where do you get the average data for the industry to compare your figures with? Where does that figure come from?
Well, the calculator that we selected here at CAFRE was the AgriCalc. So AgriCalc have approximately 3,000 to 4,000 systems already on their calculator. So what we did was go in and benchmark against similar systems within the calculator. So we took that industry average based on our specific calculator.
Great, thank you. And another question is about the fertilizer, and what does the fertilizer figure take into account? Presumably we're talking about artificial fertilizer here throughout this, rather than livestock products, byproducts.
Yeah, the fertilizer would take in the emissions associated with the production and manufacturing of the fertilizer, and also whenever the fertilizer is applied onto the soil, the nitrogen within the fertilizer would react with the soil, the microbes in the soil, and through a process of nitrification and denitrification and nitrous oxide emissions come out. So that fertilizer is both a combination of carbon dioxide and nitrous oxide emissions.
Yeah. I mean, it's quite serious, because the Haber process, by which most nitrogen is fixed from the atmosphere into the fertilizer, uses somewhere between 1% and 2% of global energy, I believe. So that is a staggering figure that we really need to think about a bit. What might be the future mitigation options for what is already a high-performing beef and sheep farm? I mean, you're presumably thinking very hard about this at the college farms, because you've got a high stocking rate, you're performing very high, but you've got, you still need to be thinking about how you mitigate against these figures that you've produced.
Yes, exactly, and that is one of the challenges with those efficient farms. We have short-term measures that we are putting in place, such as the inclusion of clover swards and multi-species swards within the grassland, but there's also a long-term project ongoing with our beef technologists in terms of genetics and genomics project, which is looking at improving the efficiency of the animal, which in turn will reduce methane emissions. So we're also looking at slurry acidification and also looking at supplements like feed for diet. But these are all kind of new and innovative technologies that need to be investigated and trialed here at CAFRE before we would suggest them rolling out to the industry.
Great. I think we were very struck by the fact that there are quite a large number of tools for calculating carbon emissions and so on. Did someone ask us, do we not need to have just one measuring tool so that we can actually compare all the data from all the different farms that are being tested? I don't know what your views are on that.
Yes, it would make my life a lot easier if we did have one tool, but yes, that is correct, and I would hope in the future that we would have one carbon calculator that could be used by the whole industry. In Northern Ireland here, AFBI are working on our carbon calculator. It's very reflective of our systems, mixed farm systems here in Northern Ireland, and we're hoping, we're working with them at the moment. We have a dairy and a beef model there, but yes, we probably need one across UK. Yeah.
It would be very helpful. With the knowledge that you now have on your carbon footprints, what do you plan to do differently on the farm, do you think, on the farms?
well, just as I was saying there, we're going to, look at the low-hanging fruit, as Philip called it, and make improvements that way. Become as efficient as we can. The likes of our beef enterprise beef and sheep will have to, look at innovative technologies. So, yes, our hill farm also, it's quite different. It has land emissions associated with it, not just the farm emissions. So, we need to be considering, we are conducting a restoration project there at the hill farm in terms of restoring that land and, stopping that emissions from the land.
Great. Thank you very much indeed, Aleathea. We're going to now move on to our third speaker, John Gilliland. John is the Director of Global Agriculture and Sustainability at Devonish Nutrition, as well as being a Director of Resourceful Organics. And he's been the Chairman of Northern Ireland's Agricultural Land Management Strategy Expert Working Group, and he is now also Chairman of a group called ArcZero, Accelerating Rumen Carbon to Zero, involving a group of farms across Northern Ireland. John, over to you.
Can you hear me now? Sorry, I was on mute. I created the cardinal sin. Can I thank you, Chairman, and thank you the Commission for giving us the opportunity to share some of our journey. And my apologies to some of the earlier speakers. I was actually late to join. I've had the privilege today of hosting one of our Northern Ireland Executive Ministers on my own farm today. So they were late, so I'm late. I apologise. But what I do want to do is just share with you a journey, and it's not a journey through one organisation. Many people who know me have known about my passion about farm carbon and about renewables, about sustainability. And really, I'm following the title of the session today. I've just added in, farm carbon, measuring and managing through the use of good science. And I'm going to wear several hats. I wear my hat as Director of Global Agriculture Sustainability, Devonish, now as Chair of the new EIP innovation project called ArcZero, which I'll explain a bit, but also share a little bit. Some of you may not be aware, for 7 years, I chaired the UK's Rural Climate Change Forum in London, answering directly to the Secretary of State in DEFRA. And actually, it was that started me on this journey and actually brought, sadly, the demise. The Rural Climate Change Forum was a multi-stakeholder forum with the farming industry on one side, RSPB, National Trust on the other side, AIC, Carbon Trust, and then DEFRA Secretariat. So it was a really interesting journey to go through. But actually, there was one area where, sorry, for some reason my slides don't want to. Just bear with me a moment. Sorry, my slides don't want to go on. Sorry, just bear with me. Stop sharing. Let's go and do this again. Are you seeing my slides there? Okay, I'm seeing nodding heads. Okay, but why does my slides not want to go on? Verity, have you got a copy of my slides there? Could I ask you, Verity, to put up? Thank you very much, and I apologize for this. Great thing about digital. If you could share my presentation, Verity, and then go to the second slide, please. Thank you. Hopefully everyone can see my second slide there. So one of the issues we came to at the end of our 7 years work with DEFRA was that this perverse situation where currently farming is only recognised for the emissions it emits. Yet if you look at fluxes of greenhouse gases, and in this image, sorry, I've also put ammonia in here. Of course, ammonia is not a direct greenhouse gas, I should say. Indirectly, it is. what you can see, as people know, we have greenhouse gas emissions, so nitrous oxide from soils, wet soils, methane from manures and from ruminants, and CO2 from machines and heating and whatever else. But what it didn't recognize is that farm landscapes, so the same farmer farming the animals also manages the landscape. It's full of plants, they photosynthesize, they lock up carbon, they release oxygen. And by locking up carbon, that is called sequestration, which currently isn't recognized, although in the 2030 European targets, they are now going to include it. And really what we wanted to do is, could we find a way of actually looking at net emissions for a farming business? So instead of looking at each individual enterprise, could we take a whole farm business approach? And when I was an energy regulator, when we put the power stations into the European Emissions Trading Scheme, we took the whole power generation business. We didn't take one bit of it. So if I could go on to the next slide, please, Verity. And really, what we want to do is try and correct this. And ideally, to do that, what we wanted to do is create a process that you calculate your annual greenhouse gas emissions. So Aleathea and Philip have gone through that in quite some detail, from emissions, from animals, slurries, energy, whatever. But you also look to add up what is your gross annual carbon sequestration. If you can do both of those, what you get then is a net annual greenhouse position. That could be emission, or it could be, you could be a net sequesterer. And a lot of people don't realize, but actually farming, some farms could already be beyond net zero in their own farm business. The point is, we don't know because we're not measuring it. We're not doing this. So really what we're trying to do in this journey is, as a result, is to create a true and transparent and fair position where each farm business is on their journey to net zero. Because net zero isn't just a country problem. Every farming business, every land management business needs to get their head about where are they on this journey. So that allows them then to make better quality decisions. So how do we do it? So Verity, can I have the next slide, please? And so I was very privileged. In 2013, I was approached by Devonish. It's a livestock nutrition and research company based in Belfast. And they decided to step into this space. And they actually bought a farm in north of Dublin in County Meath. And our objective, and I was recruited to run the project. And the objective was, could we deliver a beef and lamb system that would deliver net zero by 2025, while still delivering other public goods? And it's very important in our conversation today. This isn't just about carbon. We as land managers have to deliver multiple public goods. And so on this farm, 185 hectares of grassland and woodlands, we've got soil improvement programs, we're measuring carbon sequestration, we're looking at our overland flows of soils and nutrients, we're managing biodiversity. And if that wasn't enough, we also are part of one of the 3 UNESCO World Heritage Sites in Ireland with 6,000 years of farming evolution. So we're managing our heritage as well. And for our privilege and recognition, we were selected 3 years ago to be part of the new international global network of lighthouse farms of Wageningen University and research in the Netherlands. Next slide, please, Verity. So really to do this, go on this journey, and I see in the chat functions, some people have been asking these questions. So we started this journey in 2014. We were the first farm in the world to actually go on this journey. And we are a great believer, if you cannot measure, you cannot manage. And so you need to create these initial baselines. So for us, what we did in 2014 is, at that stage, our LiDAR was mounted on a helicopter. We did an aerial LiDAR and an ortho imaging survey. That's a smart phrase for saying a photographic survey, to measure all our above ground carbon. We did that in partnership with Chagas, with Stuart Green, who was a fantastic technician, brought it all together. And from that LiDAR, and if someone wants me to talk in detail further, I'll explain how it works and how you can measure above ground biomass in trees and hedges. You can see a 3-dimensional reflection of how a LiDAR imaging can actually show every hedge and tree in the farm. And we were able to work out our biomass density in tons of carbon per hectare. And it came as actually a surprise, but it shouldn't have been, is that our hedges had far more density of carbon than our woodlands. You can walk through a woodland, but you can't walk through a hedge. That makes sense. And we worked out our total above ground biomass, and we estimated from that what our segregation potential would be on an annual basis. And some of this work was reported in by the EPA in the south about how you use this technology to measure hedges and trees. Next slide, please. The next thing we did is we then wanted to look at what was going on below ground. So to measure soil carbon under IPCC, you're asked to do it to 30 centimeters. And I know I've got Dario on behind me, so I'm going to be very careful what I say, because he'll dot my I's and cross my T's and mark my exam sheet here. But what we did is we took representative samples. Over our farm, we did 88 soil pits to 30 centimeters. Our farm is a brown earth mineral soil, lovely soil, hasn't been ploughed for 40 years, and some of it's never been ploughed at all. And we then sent that off for sampling. And boys, did we get a shock. And the shock was our average soil carbon was 2.1% against an expected output of 4 to 5%, which blew us away. We just didn't see that coming, didn't know where it was coming, and certainly has shaped our research on our farm since. Why do we have this disparity in soil carbon levels? But at least we've got the baseline, and we intend to go back. This was done in 2017, every 5 years, to refresh the baseline and measure change in the intervening 5 years, so that you actually can look at results of different management practices on the land. Next slide, please. So when you create your baselines as such, you then go to calculators, and like Aleathea, we also went to SRUC and we used the AgriCalc. I have to declare an interest as the past director of SRUC. I actually was instrumental in getting the calculator set up, so I have a little bias, but it is a very credible one, and it looks at a whole business approach, not an enterprise approach. And we felt that was really important, so nothing would fall out of bed. You know, how do you allocate fixed costs like diesel and electricity? At least in the whole farm calculator, everything gets included, and you get a whole farm approach. And these calculators basically use emission and segregation factors. A lot of people don't realize these are assumptions for modeling, but there are different degrees of sensitivity and accuracy. Tier 1 is very crude. Tier 2 is more refined at a national level. Tier 3 is where we want to get to at an individual farm level. And certainly in Devonish and in Douth, it is our aim to get to Tier 3 in every emission and segregation factor. And that's the core of our research to get there. And doing these baseline data at the landscape level and repeating them every 5 years will allow us to see actual segregation. Next slide, please. So what we found in Douth is on an annual basis, between our soils and trees, we're segregating 665 tons of greenhouse of carbon dioxide equivalents in, you know, as I say, in above and below ground. But what I didn't understand is what does that mean in relation to the number of animals we have on the farm? And if you listen to a lot of public debate, they said, well, the easiest answer to get agriculture to net zero is to get rid of animals. So what I've done in this, just to give you an understanding of our thought process, is we have sensitized our potential journey to different livestock density, different stocking rates. So on this bar chart, along the x-axis, I've got stocking density, going from 1 livestock unit per hectare up to 2.5 livestock units per hectare. Up the y-axis, I've got total greenhouse gas emissions for Douth on an annual basis. So if I start on the left-hand side, at 1 livestock unit per hectare, we can have 91 cow-calf equivalents, whose gross emission is 580 tons coming from the calculator. Less than 665 tons means that 1 livestock unit per hectare, we are already beyond net zero for Douth at -76. If I go to the other side, so if I'm a derogated farm at 2.5 livestock units per hectare, I can have 228 animals whose gross emissions would be 1,451. Less our 665 tons, meaning our net position would be a net emission of 795. So that orange yellow line across that is really our net position over different stocking densities. Where we're in Douth at the moment, we're not a derogated farm. We're stocking at 2 livestock units per hectare, and currently our net footprint is 496. So we're displacing about 56% of all the greenhouse gas emissions we produce, we're displacing through segregation. The question then is, I have put my neck in the noose, and I've committed to the board of Devonish that we will deliver net zero by 2025. So how do I do it? Well, the easiest answer is I get rid of animals. And in Douth, the sweet spot in Douth today is at 1.25 livestock units today, I would be net zero. But my problem on that is there is still a marketplace wanting to eat livestock products. And if I don't produce it, someone else will. And they may produce it from a farming system that may be far more carbon intense. So we have taken a decision that we're not planning to destock, but we're going to use the best of science and innovation. And really what we're trying to see is how at 2 livestock units per hectare can we get to net zero or beyond. And that is the agenda that we have set ourselves in Douth. Next slide, please. The very first thing we went back, and this is no different to anyone who's read the Sustainable Land Management Strategy report for Northern Ireland will know, soils are the first thing you need to look at. And in livestock production, it would be fair to say the majority of us have focused on the animals and have forgotten about soils. So we have gone back and we have looked at soil pH. The work that Dario has shown in his published papers, that there is a strong link of soil pH on mineral soils with segregation. So what did we do? We went and looked at our soil pH back in 2014, and we found it was awful for a mineral soil, 5.5. So what we've been doing a little bit often, putting a little bit of lime on and putting on where it's needed and not what it's not needed. And every 2 years we test our soils. So what you can see there is our journey in soil pH over a 6-year period. And we're looking to hit 6.5 pH, and I'll explain why in a moment. But you can see in our journey, we have dramatically improved our soil pH. And if I looked at our grass utilization of those 6 years, we've gone from a utilization of 4.1 tonne to 8.8 tonne per hectare on our permanent pasture over 6 years, just by correcting the soil pH. Next slide, please. The second thing, and Aleathea alluded to this, we're probably a little bit further ahead in regards, we secured a very large research project from Horizon 2020 under the Marie Curie programme. We secured €1.4 million with Wageningen University, University College Dublin. We have 5 PhD researchers, and we've devoted 36 hectares to multi-species trials. We have 4 different sward compositions looking at the permanent pasture, straight perennial ryegrass, 6-way mixtures, 2 grasses, 2 herbs, 2 legumes, and a 12-way mixture of 3 grasses, 4 legumes, and 5 herbs. And we're now well into 18 months there, and we've had dramatic results. Just to give you a highlight, at the end of the first grazing season, we had dropped nitrogen application by 70%, but we had increased productivity by 15%, and we see a 70% increase in earthworm populations under the multi-species swards than we do in the perennial ryegrass. So really driving soil health, animal health, productivity, but reducing greenhouse gases at the same time. Aleathea, next slide, please. The third area is building on the tremendous success in Northern Ireland of AFBI's work in Loch Gow. AFBI have the longest trials in agroforestry and silver pasture anywhere in Europe, led originally by Jim McAdam, and sadly Jim is now retired, but he's still a passionate advocate for it. And what they have seen over the 30 years, that silver pasture, in that case ash with grass, they've been sequestering 2.4 tonnes of straight carbon per hectare. On grasslands, somewhere between 0.6 and 1.2 against a forestry plantation of 3.8. So certainly if you're looking to drive your journey to net zero, putting some of your grazing platform into silver pasture, where you have animals and trees coexisting, driving carbon sequestration, driving biodiversity. On the right-hand side, you can see some of their results on biodiversity benefits are quite dramatic how well silver pasture have done. But the most important thing for me as a land manager, the thing that isn't talked about, is the role of silver pasture to making your soil more trafficable. The expert working group in Northern Ireland did a second report on making ammonia visible. And one of the key things we said to reduce ammonia emissions is keeping your animals out of grass for longer. Ammonia only happens when feces and urine mix. They rarely mix when they're out grazing. So being able to extend soil trafficability by 17 weeks a year means that you can reduce ammonia emissions, you can drive grass utilization, you can drive profitability. So we think in a grazing platform fit for the 2050 with having to adapt to climate change, silver pasture has a real role to play at maybe a 20%, 25% role in your grazing platform, and getting that carbon sequestration and driving biodiversity as well as driving profits. Next slide, Aleathea. So the last part of our strategy was to look at what is in the science and innovation pipeline out there as well. Now this image I'm showing you, I've actually borrowed from our partners in Australia, ArcZero, which is the Commonwealth Science Industry Research Organisation, an extension of the Australian government. And this is from their National Livestock Mitigation Programme. I've used it because it graphically gives you an understanding of some of the technologies that are out there, some of them in the pipeline, and their mitigation ability, and also their barriers to implementation. So each circle there is a different technology, and you can see a name beside it. Up the y-axis, you've got their potential for methane mitigation. Out the x-axis, you've got your barriers to implementation. If I start right down at the bottom left-hand corner, the yellow one, that is genetic improvement of dairy animals. We know, and certainly Northern Ireland has benefited over the last 30 years of improved genetics, improves greenhouse gas emissions per litre of milk or per kilo dry matter solids. The big mustard circle above that is vaccination program developed by New Zealand about using vaccinations to mitigate methane from the rumen. More interestingly, if you go to the right-hand side there, the red circle is biochar charcoal. Certainly if you feed charcoal within a diet, you will reduce methane. It just has no nutritional benefit. Above that, that blue one, that royal blue one is bioactive. So that's garlic, that's citrus, and certainly does have some impact. Sadly, sometimes known to taint the milk. Above that, you see a little blue circle called NOP. That's actually a synthetic product coming from the nutrition company DSM in the Netherlands, 3-NOP, and they are looking to get regulatory approval for 35% reduction of methane. For me, the most interesting one, and one that was shared with the British Society of Animal Science 2 weeks ago at their conference, is the work of macroalgae, red seaweed, Asparagopsis. And certainly the work that's been done by ArcZero in Australia and by UC Davis in California, they're seeing somewhere between a 60 and a 90% reduction in ruminant methane by the addition of 0.25 to 0.5% of dry matter, this freeze-dry seaweed. Really interesting technology, and nature-based technology should get organic approval if we can learn how to grow it and make sure it's safe. So we believe that certainly that over those 4 separate journeys we're taking, that will drive us to net zero and beyond. Next slide, please. So the next step for the journey that certainly I've participated on is, can we now move it out of doubt, and can we now replicate this? So we are very flattered and humbled that we secured funding through a DERA call led by CAFRE, the EIP innovation call that happened last year during lockdown. And I and 6 other farmers came together. It's about supporting farmer-led innovation, and we secured funding to see could we repeat this on 7 farms across Northern Ireland. And the idea of this project is now up and running. The soil sampling is now done. The LiDAR was done on Saturday. Is can we deliver gross emissions, gross sequestration, and the net carbon position for each one of these 7 farms? Can we also at the same time look to improve soil health, water quality, nutrient efficiency? So can we deliver multiple goods? And our partners, we have really credible partners. AFBI are helping measure the carbon in trees and hedges and doing the soil and phosphate runoff risk maps. AgriSearch are helping us in the communications. Devonish are then going to combine it all and put it into a net farm carbon calculation. Queen's are helping us with the soil carbon work, and SRUC are helping us with the agri calculator for gross emissions. So a really credible project, but farmer-led innovation, looking to replicate this on 7 totally different farms in 7 totally different regions of Northern Ireland, to start seeing how does it look on different farms and different geographic regions, different soil types, different climates. Next slide, please. So really, that was a quick dash through, but hopefully you've got a feel of the journey we're on and how we believe we can deliver on farm carbon. Critical is around measuring and managing, and fundamental is how you use good science to bring credibility and transparency to our journey. Thank you very much, Chairman.
John, thank you very much. Usual, very, very fascinating and stimulating stuff from you. Wonderful. We've got a few questions here very, very quickly because we're a bit short of time. But I think a really important one is about LiDAR and how it actually works and what does it cost. Can you just give us a quick idea on that?
So let's talk about how it works first of all. So as a plane or a helicopter or a drone flies over, it sends a laser beam down. Unlike satellites, satellites do like a scan per 10 square meters. On LiDAR, we're doing 40 scans per square meter. So the intensity of feedback is extraordinary. So as a laser beam goes down, some of it may hit a tree or a branch of a tree and bounces back very quickly. Some of it gets through all the branches and hits the ground and bounces back slower. And you can go to the computer and say, with this data set, only show us the slowest 10% of the returns. And when you do that, you get a naked landscape, a bit like the image that Aleathea showed. It is a naked image. You can then say, well, now superimpose the fastest 10%. The fastest 10% are from the laser beams that bounce off the outsides of trees and hedges. And that then gives you the 3-dimension, accurate 3-dimension of your landscape. So now you can work out volume. You then go and look at your ortho imaging survey and you can look at, well, what kind of tree is this? You know, and you can go to your tables and say, okay, that's hawthorn or that's sycamore or whatever else. And you can work out then its carbon density, and that gives you a carbon stock. And if you know what your carbon stock is, you can then currently use a sequestration factor to give you an assumed annual sequestration. But the benefit is if you repeat the LiDAR 5 years later, you can actually measure change. And really where we want to get to is we want farmers to be rewarded on positive change. And so a farmer does really well at this and sequesters a lot of carbon, they get rewarded for it. And the public purse can be reassured that they delivered what they said they had delivered, because it's a really accurate digital tool. At the moment, the technology is expensive. But in every new technology coming, the technology starts expensive. But you know, I absolutely, as chairman of the expert working group, we have really welcomed how DAERA have embraced LiDAR. We've had now LiDAR surveys done in the Upper River Bann, Catchment, in the Colebrook, the Struel, and the expert working group will continue to encourage that this should be rolled out as a public good over the whole of Northern Ireland, because we think it is an extraordinary tool to measure natural capital. And if you repeat it every 5 years, you can see real change and you can build future government policies to support farmers delivering public goods in a way that's measurable, that taxpayers can see they're getting value for money, and farmers can be rewarded for the positive change. And for the farmers who don't want to go on this journey, that's fine, but don't be asked to be paid for it. You know, this whole thing, public money for public goods, this technology allows you to do that. In regards costs, in Doubt, the LiDAR cost us £13 an acre. I believe suddenly if you're going to do whole landscapes, you could get that cost down, because the biggest cost is actually getting the plane or helicopter mobilized. That's the biggest single cost. So if they're going to do 5,000 hectares and not 50 hectares, it's, you get economies of scale. So fingers crossed.
John, can I stop you there, because we've got to have fit in another presentation. We have a series of questions about pH, but I think I'm hoping that Dario may actually address some of that in what he's going to say. So we'll move on to our final presentation. Thank you very much, John, for yours. From Dr. Dario Fornara from the AFBI, the Agri-Food and Biosciences Institute. Dario, over to you.
Thanks, Patrick, for your invitation to this webinar event. Can you see my screen now? Thank you. So it is very exciting to see all this growing interest in agroecology, which is about finding the right balance between productivity and the sustainability of agricultural systems. From my side, I think one key challenge remains how to maintain and improve soil health and soil resilience, and allow soils to keep doing their job, which is actually cycling and storing key elements for life, such as carbon, nitrogen, and phosphorus. So in relation to soil resilience, I've just included this picture from the recent Kiss the Ground movie, because it is very effective in showing what might happen if we keep mismanaging the soil for a long time, which is going to create massive soil carbon losses, soil erosion, changes in climate, as you can see on the left side of this picture. Fortunately, Northern Ireland, we are more on the right side of the picture, and possibly where the green tractor is and where the agricultural grasslands are. In this case, though, we need to improve our understanding of what management practices can actually help us to move towards this agroecological transition, allowing soil to store the carbon and also cycling the nitrogen and the phosphorus more conservatively. So over the next 3 slides, I'm going to show how soil carbon sequestration, but also soil health in general. And I feel I'm going to reiterate a few of the key messages that John has just presented here. I'd like to start with a very common practice, which is the addition of organic amendments to soils. And in particular, I'm focusing on the application of cattle and pig slurries to soil. What you see in this graph is findings from a long-term grassland experiment that was established at Hillsborough in 1970. So on the y-axis, you can see soil carbon stocks in tons of carbon per hectare. And on the x-axis, the time from 1970 to 2020. So what this graph shows is basically increases in soil carbon stocks between 0 and 15 centimeter soil depth in relation to different nutrient additions. If you look at the legend on the right side of the graph, starting from the top, cattle age means high applications of cattle slurries, and then medium and low applications. And then the control soils, these are soils that have not received any nutrients over the last 50 years. And then NPK applications, nitrogen at rates here of 200 kilograms of nitrogen per hectare per year, and then 3 different applications of pig slurries. I guess the key message from this graph, well, there are 2 or 3 key messages. The first one is that cattle slurry applications are associated with greater soil carbon stocks, so greater rates of soil carbon accumulation. The other message is that all these plots, regardless of the nutrient treatment, have actually increased carbon stocks over the last 50 years, which suggests that these soils have not reached a carbon equilibrium yet. And the other thing is that actually NPK and control treatments are not significantly different between each other. So it looks like inorganic nitrogen is not as effective as maybe organic nitrogen in stimulating accumulation of organic matter in these soils. Well, a trade-off between this kind of organic amendment led increase in carbon sequestration that we need to consider is that we need to be careful about our cattle slurry, the quantity of cattle slurry that we apply, because then phosphorus and nitrogen will also increase, and the benefits from carbon sequestration might be actually lost by losing the phosphorus and the nitrogen from the system through leaching, for example. So the second, well, another important management practice is related to the addition of non-nutrient fertilizing materials to soil, like agricultural lime. So here I just wanted to summarize findings from different studies that we carried out over the last 10 years in relation to liming effects on different soil and plant parameters. So if we start from the top on the left side, what we have been finding is positive in general, either non-negative or positive effects of liming on soil carbon stocks, but also on the carbon pool of small soil physical fractions. If you look on the right side, this picture basically shows the soil that has been fractionated through different sieve systems. You know, soil is not homogeneous, it is a heterogeneous kind of system, and not all the particles, not all the physical fractions basically have the same function or could tell you about the ability of these soils to sequester carbon. In this case, liming is basically helping moving carbon from large macro aggregate fractions to small ones, including micro aggregate and silt and clay fractions. So the positive thing about this is that that carbon is more recalcitrant, is more resistant. It could stay in the soil for a longer time. What we also seen is a positive effect of liming on the abundance of arbuscular mycorrhizal fungi, which are particularly important because they improve soil structure and help the plant uptaking phosphorus from the soil or nitrogen, for example. If you move down, we have been finding positive effects of liming also on nitrate levels in the soil. Not really effects on soil phosphate levels, and positive effects on root decomposition processes, which again suggest that organic matter is broken down and nutrients become available to be recycled within the system. We also found increases in bacterial biomass. We found positive effects on plant nitrogen use efficiency. So these plants use nitrogen more effectively, and we've been seeing positive effects on plant yields as well. In relation to composition, there are no clear effects on plant species diversity, and it seems though that by regularly liming these grasslands, the abundance of legumes is increasing, or at least it has been maintained. So legumes can fix the nitrogen and possibly reduce the need to add artificial nutrients to these soils. And finally, we've been trying to find out what are the liming effects on other microbes in the soil, other fungal communities, and also on total root mass, because that's also important, because carbon inputs to the soil mainly come from root systems. Okay, so the other management practice that I wanted to mention is one that is becoming more popular across the UK over the last 10-15 years, which is actually the seeding and the establishment of multi-species swards. So the key issue here is improving biodiversity and actually benefit from the range of ecosystem services that could be provided by a larger number of plant species growing together and coexisting in the same grassland community, as actually John already mentioned earlier. So in terms of management, if you look at the two graphs on the left side, it's like moving from an intensively managed ryegrass monoculture, which likely is, well, has got lower efficiency in resource acquisition and use. And for resource, I mean water and soil nutrients. Moving towards then a greater diverse sward, which includes multiple species, which are different in terms of like root mass structure and also canopy. So the coexistence of these species, the ability to utilize nutrients at different soil depths, but also utilizing resources across the season, because not all these species have an optimal growth at the same time. So you can benefit from having legumes, C3 grasses together, forbs, because they will utilize resources better across the growing season. So we're moving from a low efficient resource use to a more, to a better resource use efficiency. The graph on the right is just to show you evidence from two long-term experiments, one in Germany and one in North America, which have been looking at the potential effects of different species numbers on different ecosystem services. So if you look on the x-axis, we have the number of species changing from 1 monoculture to 16 species coexisting together in both experiments. And then on the y-axis, it is an index, a proxy, to measure changes in different ecosystem services. So you can see, as long as you increase the number of species, then there are benefits for yields, for soil organic carbon accumulation, and for the stability of this yield, because that stability is important in relation to climate change. If we get few weeks of dry weather in the summer, or actually more variable climate, then having more species coexisting, it will give you more stability. The yield may not actually collapse, but they will be more consistent. And then there are other ecosystem services delivered in relation to pest suppression, weed suppression, and also in general soil fertility. I think what we don't know at this stage is actually whether all these ecosystem services are delivered on commercial farms. So what I mean here is that we need more knowledge, we need more information, we need to address how multi-species wards have been providing benefits across different farms on different soil types. So we need a network of farms. In Northern Ireland, we have one already, the Beacon Network farm, which is going to provide fields where actually these measurements can be carried out. In relation then, so then we know what kind of management practices can actually contribute or might contribute to increase carbon sequestration in soils, but also improve soil health in general. What we're still missing is more knowledge and more information about how soil carbon stocks might change across farmed landscapes, how different management practices can actually interact with each other and with land use change to affect carbon stocks in the long term. So 2 years ago, we proposed this, I would say, comprehensive approach, which is based on measuring, reporting, and verification platforms. I don't want you to pay attention to the detail here, but only on few key aspects. So the first one, what we need to do is to identify across Northern Ireland benchmark sites where we actually can start measurements which could be repeated then every few years. These benchmark sites could include long-term experiments. Maybe we have them already, maybe we can establish new ones. At the same sites, we need to come up with ideas and hypotheses. We want to test the effects of multi-species worts and liming together, or maybe organic amendments. We need to carry out experiments and generate data, which can then be fed into models. And then when we have these models, we can make long-term predictions on changes in soil carbon stocks. We also need technology. We need Lidar, we need remote sensing, we need GIS. We need to map these changes and show how they might actually continue in the following years. And we need to go back again to the same place, as I said, every few years, because we need to follow changes in soil carbon stocks in the field. And finally, so this is my last slide, because we're talking about agroecology, I think one key element of this agroecological transition is really trying to diversify landscapes. If you look on the picture on the left side, this is a picture of the research platform that we have at Loughgall. So where we have permanent grassland, silvopastoral systems, woodlands. So it is a mosaic of different ecosystems, which at the landscape scale will provide the diversity you need to probably move towards these agroecological kind of new farmed landscapes. So the diversity is not only at the field scale, maybe using multi-species words. It's about having a vision of improving or increasing diversity at the landscape scale. How to get to that stage? Well, there are different approaches. On the right side here, I've just copy and pasted a framework from a recently published studies which suggest to take a multi-level assessment. So maybe you could have 2 different farming systems or more, multiple farming systems, and you start looking from the bottom up. So you start from the soil, you measure key variable parameters in the soil, and then you look at micro and macro diversity. You look at what organisms you have and what they do, and you then not only look at carbon sequestration, but you look at different ecosystem services, nutrient cycling, nutrient storage, water, and then you have a data set which will inform you how to get to implementing agroecology within farmed landscapes. So I know I had only 10 minutes, so I put together 6 slides. I hope it was about 10 minutes. Thank you. I'm going to stop here.
Thank you, Dario, very much indeed. That was great sort of conclusion really to our discussion today. Unfortunately, we have now run out of time, but I think it has been well worthwhile to hear John and Dario's presentations there as to how we're moving forward on this. There are lots more questions, and we'll do our best to try and address those in the process afterwards. I know that John has already answered some of the questions through the chat function. It remains for me just to say a huge thank you to our contributors today, to Aleathea, to Phil, to John, and to Dario for their contribution, and to thank all of you for listening in and for contributing so many interesting questions and comments. As I say, it will all be available online in due course, and I hope you will have a chance to revisit it if there's anything else you need to check up on. Thank you all, and a huge thank you to Verity for putting it all together.
Thank you.
Thank you.